That is, right, so we are recording. That is not on the right slide. Give me 1 second. If that fixes it. Should fix. Right, 1 second. Gotta have to change all the display settings. Really annoying. Oh. Sorry about that. Forgot I needed to change. We're having a great. We're not on the screen. All right, so today we're just gonna talk about lab expectations. So with this, we are going to just be talking about kind of some lab report stuff. And so with that, I want to talk about the different parts of the lab. How many of you have taken different science class here at the campus? Okay. So you guys have written a lab report? That kind of means for writing a lab report. But what does that mean?
The lab report, we have to turn it in, and she doesn't need to specific on what we recorded.
Huh.
We just kind of use it for reporting. And
Interesting.
analyzing data.
Okay. Right. So, with this class, we will be doing some amount of writing for a lab report. Because one of the most important things that as an engineer, you need to do is be able to communicate what you know to somebody who may or may not be an engineer. And so with that, just kind of want to work through what some of this is with it. So a lab report, so this can be done in groups. Probably going to be pairs is going to be where that is for it. So if you're doing it as a pair, we'll talk about that in a little bit. But right, you'll be able to do that. You can also write it as an individual. I'm not against that. If you are working in a pair and you find out that maybe your lab partner is not the best lab partner and you don't want to talk to them, I can go through and do that. So I can talk to them and be like, hey, you need to either step up and do your work or write your lab. I don't know what's going on. Give me pause all this. Figure out what's going on. Wondering if when I was playing with it earlier, I recorded some stuff, so. Here. Everything. Also maybe fix it so I can actually see my own slides. See if this works. Okay, I don't know what's going on. Not having a great time with that, so. Figure it out later. Wish I could say this was the first time this has ever happened, but it's not. All right, well. I'm gonna try one more time. Sorry about all of this. Also, this might have to power cycle that. One more time.
It's an exciting series of.
It really hasn't. In here all day having fun tech times. We'll see if I can at least get it to do it. Can you tell me where my cursor is? Oh, there it
It's right.
is. There we go. Perfect. Duplicate. There we go. Okay. Finally got that working. Apologies. All right, so, for labs, right, you can work in pairs. I can be the bad guy if you need me to. That's not a problem. You're gonna turn these in on Canvas. So, if you are turning it in as a pair, ask that you do one person turns it in. So what's gonna happen is on my end, I'll set it as a group assignment. And then what will happen is one of you will turn it in. When the lab assignment closes, I will go through and I'll look at all the labs, and if both of your names are on there, I'll put you in a group. That will automatically merge it such that any comments, I put what I grade on the rubric, everything is visible to both of you. So if you do it as a pair, please only have one person submit. If you both submit, I do not know how it picks which submission is the submission. So just submit it as one. I know for whoever doesn't submit it, when the assignment closes, they'll show up as a 0. Don't freak out. Get it adjusted. Give it a second. So I have no minimum page or word count. But with it, if I ask you for something, it should be there. Very often with what we're gonna have, we're gonna be doing you're gonna do some pre-calculations or some explanation, have your results. That's kind of the main focus of what we'll be doing. You can do more than what I ask for, but you won't get graded on it. I'll give you comments, but. So for writing, in this class for the lab report, we're gonna pretend that we're writing it to another section of circuits. And so with that, we'll be going through and it'll be, right, you can use the jargon, you can, but if it's kind of the main point of the lab, you should be spending the time going through and making sure that you are explaining that. So for example, our first lab, we're going to talk about we're going to use resistors. You should probably go through and explain what a resistor is versus, by the time we get to our 6th lab, there will be a resistor in that one as well. You won't need to explain it then. By week, whatever, 12, I think, or 13 it is, you should know what a resistor is. So first time you see it, maybe the second time, explain it, but beyond that, you don't necessarily have to. If you're writing it as an individual, I'm totally okay if you want to use first person. That's not a problem for me. But if you're writing it as a pair, you should use we. I don't think you're going to ever write a full lab report for this. Engineering of anything in science, I think has one of the widest ranges of what is used in terms of how to actually write it up. So there are different types of report for different types of engineering. There's even within mechanical engineering, I know there's a lot of different ways to format it. We're just going to practice taking results, formatting them nicely, introducing some stuff. Just kind of practice answering some questions on it. So I doubt we're going to write a full lab report. We'll talk about a full lab report in case you want to kind of see what that goes into. But again, that tends to lean a little bit more research-based. That's not necessarily what everybody's ever going to be writing. I'm going to go through and talk about the sections of the lab report. Regardless of what your lab report is going to be, the front page of your lab will always be like a what to turn in. So that will tell you the things I'm actually looking for that particular assignment to go through and grade. So please put the title on there. This is kind of twofold. One, you are not my only lab class, so I don't want to act like think that I'm grading the wrong lab. Also, if you accidentally upload the wrong file, it's a lot easier for me to check and just not be confused that you just somewhere maybe you added new stuff or whatever. It just tells me right away, like, hey, this is the wrong lab. So please put a title on it. Please put all names on there as well. I know for Canvas, if you're turning it in yourself, right, it's under your name. And just nice to have it there as well. So please put your name on it. If you are working as a pair, you are responsible for making sure your name is on there. So please make sure your name is on it. So the abstract, again, this is something that I don't think we're probably going to be writing. Talk about it just in case you guys want to know what it is. Also, it's a nice little skill to know. Basically, the idea of an abstract is to hook your reader into actually wanting to read the rest of your report. I am under obligation to read it, so read it regardless. But basically, it's a nice summary of what you're doing in the report. And it's typically about one section per lab, or per section of the lab. You would have an introduction of what's the main topic are you covering. In this lab, we are covering or looking at the difference between resistors in series and parallel. Boom, there's your first sentence of your abstract. For the methods, you would talk about how that is done. So if you're using a simulation, what simulation? If you're using a circuit board that belongs like a certain type of circuit board, you would need to acknowledge what that is. So basically, a just brief statement of here's how we tested it, and then this is what we found. So your big result at the end. So again, don't think we're probably going to get to actually writing an abstract, but as of right now, I don't think you're going to, but if I make you at the end, this is what it is. So the introduction is something you will be writing. So the idea of the introduction is you're trying to give all the background information. So the first thing you'll be doing is talking about the topic, the primary topic for the lab. So this can be done in a lot of different ways. You can talk about the physical phenomenon that's happening. So later in the semester, we'll be doing a capacitor lab. What does a capacitor do? All right, you would go through and explain it here. Different schools of thought think differently for where to put equations. I'm big on putting them in the introduction, but you don't explicitly have to. If you're putting it in the introduction, what I would recommend is you have your equation that's relevant to the topic, and then you need to define your variables. I don't care that capital R in this class is always going to be resistance. You need to explicitly put that there. Because as we'll see when we talk about current, sometimes it's capital I, sometimes it's lowercase I. We need to make sure that our reader understands which one that we're using. And with that, even though some, again, are always used, like resistors always are, it's a good practice to have to always just label all your variables. Why is it important to study this? Why should I care about a resistor? Why should I care about an RC circuit? Why should I, what's an amplifier? What importance does it have? Basically, it is trying to take, why do we care? Why am I making you learn this in the first place? If you're in a circuits class, why is circuits important? That's kind of what this here is. And the last thing is a hypothesis. So a hypothesis is defined as an educated guess. It's not just a guess. You have to be able to back it up. So with being able to back it up, that can come from the fact that you just wrote about what it is. So for example, let's say you're talking about resistor circuit, and we are talking about series and parallel, which we'll talk about here in about a week. right? You're gonna describe it here. What is series? What is parallel? You're gonna explain it, and in the hypothesis, you can say, based on above, we expect whatever behavior to happen. So for the hypothesis, you need to have some sort of education part of it. So whether that's doing some math to calculate a value, giving an equation, explaining the phenomenon, some way to back up why you think what you think. In general, is it okay to be wrong in science or engineering?
Yeah.
Yes. So, does your hypothesis have to be correct?
Yeah.
No. If your hypothesis is wrong, perfectly okay. Fine. Nothing wrong with that. And in fact, some of the stuff we're going to do, your hypothesis is going to be wrong, probably because you don't know the exact value for the resistors you're using. So it's okay for the hypothesis to be wrong. Once you have results, you don't need to go back and change your hypothesis. Let it be wrong. That's okay. So, okay. Won't lose points for it as long as you have the educated part of the guess. So as long as you've explained why you think this is going to happen is going to happen. Good. Any questions on the introduction? Methods, I'm going to be giving you the methods. So my thought process is that you don't have to write this part pretty much ever unless you are explicitly making a decision. So if I give you options, I say use this type of circuit or that type of circuit, you would then need to explain which one you use, but that's the extent of it. So I'm not going to make you write this part. So we're going to spend some time talking about the results after I go over the different parts of the lab. But with the results, we want to make sure that we are representing our data in some sort of nice, readable manner. And so this can be done in graphs, tables. Sometimes you'll want to use a sentence to just say like, very specific piece of information, but it needs to be readable and it needs to be clear what is in that table or in that graph. So with one of the programs that's we're going to be using that's in the lab kit, it makes the graphs for you. They are nice, they are labeled. You can use those directly. However, if you are taking a picture of your dirty screen with a glare on it and I can't read it, I am going to be extremely upset. Or better than that, all of you know how to take a screenshot, I'm assuming. If
Windows screen.
what?
Windows screen print.
Whatever it is, right? Snippet, whatever, screenshot it. I don't care. Do not take a picture of your screen. Think you're better than that? Please don't prove me wrong on that part. Talk about some graph table stuff a little bit later, so things to consider there. But everything that you are recording needs to go into the lab report. So if you're using multiple resistors, you should have a table that says all the resistors you're using. Or instead of having it in a table, you can have it in a circuit diagram. Right? There's different ways we can represent it that makes it clear what is being used and where. Or you can take a picture of your actual circuit. In that case, a picture is fine. However, please make sure it's clear. Like, don't have it so zoomed out, I can't see what the resistors are. Well, again, we'll talk about this a little bit later, but please be sure you explain what it is. Don't just give me a random graph. I need to know what that graph actually corresponds to. There is a high chance that for some of these labs, you're going to get a really weird reading every once in a while. If that is something you are still presenting as your data, you need to tell me why you think that one is weird. So fingers crossed, all of our resistors are perfectly fine, but when your resistor fails, it sometimes catches on fire. So if that was something that, let's say, theoretically happened while you're doing it, is your circuit caught on fire and your data started getting really weird, you could point that out. But again, shouldn't happen in this class. But if something weird is there, You can point out, if you think you know what happened, you can put it there. If not, you can say, we should probably ignore this because it's, 5 times the normal value or something like that. So any question, like I said, we'll come back to some results specifics in a little bit, but are there any general question on results so far? So for the discussion, this is typically done, there's a couple things that I look for in here. The first one is based off of your results. Where you, we'll talk about the results in a second. So you have your results. Were you kind of successful in proving stuff in the lab? Is this a good way to show that this is useful? Right, so you should readdress the hypothesis. Were you correct? Were you incorrect? Why or why not? So with this here, when you are doing your your tables and graphs, we're going to talk about it. They should be labeled. So it should say like table number, image number, or sorry, figure number, whatever. Be specific. Don't just say based on the data. What data? Which particular piece shows that you are correct or incorrect? Link to the results in the introduction. It says parentheses here or physics because sometimes with what we'll be doing, especially here at the beginning of the class, we'll be talking a lot about the physical phenomenon that's happening inside of a circuit and what's happening in a resistor or a capacitor or an inductor when we get to those topics. So sometimes you might need to talk a little bit about the physics that we're introduced to. But, is this a good way to represent, like I said, what we expect to see? This part, I'm a little, again, I don't want to focus on this part here because this is something that's a little bit more relevant for research type engineering papers. Hypothesis is done regardless, and also if there are questions in the lab handout, those need to be answered as well. I think for 1 or 2 of the lab handouts, it kind of has you, the question is about talking about your hypothesis. You don't need to do it twice. Do it once. But so there's the discussion again. Why are you correct or incorrect with your hypothesis? And then answer any questions that are going to be in the lab. Those are the 2 main things you'll be doing. Any questions about the discussion? Conclusion, summarize the report in 1 to 2 sentences, nothing wild. Again, like the abstract, we're probably not going to do this, but this is typically what they would represent. Just nice little summary of like, this lab was successful in showing whatever topic. That's typically, at least at the non-published level, what a conclusion looks like. So we're going to spend the rest of the time that I have planned out for today talking about the results. And so with the results here, there's a couple different things I want to go through and talk about. What I'm going to talk about here is not explicitly an end-all, be-all, or what some stuff looks like. Please understand that this is general, not superficial. All right, so math. This is my biggest pet peeve. All of lab reports showing math. You should always, always, always show the basic equation. So show the equation that you're going to see in the textbook that says this is the equation for capacitance or whatever. Start with that. Show me that equation. If the equation you're going to be using is derived from the basic equation, what you can do is you can have the basic equation, have the derived equation you're using, and then go through and just utilize it that way. So what do I mean by that? Well, here's an example I worked on before. So this is, the equation for the slope on a line. So we have our y is equal to mx plus b. This is the general form of the equation. I'm not gonna care if you number the equations, this is the super formal way to do it. I then have all my variables defined. All it says is rearranging, then it has the rearranged version of the equation. I don't need you to show me how the algebra works. Trust that your reader, which is me, can do the algebra to get from step 1 to step 2. So you do not need to show every little step of rearranging. Equation, what you actually are going to be using. And then with this, let's say for equation 2, here we have a bunch of numbers. Don't plug them in. Don't actually show me the actual math that you're doing. Again, it should be clear, which we'll talk about in the next couple of slides. It should be clear what number should go where. And then if I really wanted to check, I could plug it in myself. So do not show me math. One of the first lab we're going to be doing does want you to show some math, but that, or to say what the expected value is. You're welcome to show some of it. You don't have to show all of it. I'm just saying that, right, you can, again, starting equation, rearrange the equation, what values go where, answer is perfectly fine for this class. Any questions about math? All right, so tables, figures, graphs, they all must be labeled and captioned. If you do not do this, you will immediately lose 1 point. Your first couple of labs are going to be 10 points, so you'll be starting at 90% if you don't do this. So a label is going to be just saying, right, it says table, figure, graph, and then a numerical value typically is how it's done. Or you can use letters if you want to, whatever it is, just be consistent. And then the caption is a short description of what is in that table, graph, or image. So doesn't have to be super specific, but just have something there. So I will tell you what the traditional positions are. You don't have to do them traditionally as long as they're close by. That's fine with me. Traditionally, all graphs are labeled as figures. So you only have 2 things. You'd have figures, tables. If it's not a table, it's a figure. Figures are labeled below the figure and briefly indicate what is being shown. Tables are labeled above the table. Again, this is traditionally. I don't care if you do it this way or not, as long as the label and caption are close to whatever it belongs to, that is perfectly fine with me. If you want to have graphs, have it be called graph 1, 2, 3, 4, 5, that's fine. Does not need to be labeled as a figure. So, as long as it's included, and again, as long as it's nearby, don't have like a giant list of labels and captions somewhere else. Label and caption as close as possible to its particular thing it belongs to. So let's practice this labeling and captioning skills here. So let me explain what this picture is before I set you guys loose on trying to work on it. But you're going to practice labeling and captioning this particular image. So what we have here is I am very right-handed. So the top left star here, these are all drawn on a touchpad. This is with my right hand with my eyes open, my left hand with my eyes open, my right hand with my eyes closed, and my left hand with my eyes closed. So what I want you to do is with your neighbors, how would you label and caption this particular image?
The goal is one figure next to right and forward, and the top left is right. Sorry, the left side is right hand, the right side is left hand, top is. Eyes open, eyes closed.
Are we doing like each one is its own figure?
You tell me.
left side, right side are all, it all would be either here and one after. Top one's drawing. Eyes open, you just have to get the strong eyes closed. Yeah. Oh, yeah, like, so it's like that. And then just saying, like you're saying, top one's daughter, it's how they or that one top one started. You just put it at the floor, it's also like one figure two, right? Hey, you could basically tell you. That's what it meant, like that. There's also video. You probably gonna figure, just keep the indentation too.
Right, so who would like to volunteer? How would you go through and label this?
Volunteered.
Sure.
So I said I would probably just label the whole square as experiment one, and then I would put a description down. Saying top left star, what I did, top right, in parentheses, I did, bottom left, bottom right.
I'm not rewriting it.
Huh?
Yeah, I'm not gonna write it out. Yeah, yeah, you just like what I basically told you. Yeah, that's fine. That's one way to do it. I heard some other ways. So one, yeah,
Like split and like. So you can either just have it, just say, no, figure one, it's just this left side was done with my right hand, and the left side was done with my left hand, and you say that. The top two, which are with my eyes open, bottom two, which are with my eyes closed.
so talk about top, bottom,
Yeah,
left, right.
or you can just split it into different subsections, like figure one, like one.
Is that what you were gonna say? Yeah. So- Yeah, so you can also,
The other way you can do is label each one of them and then just write your thing right out with your.
yeah, so you could also do the classic, the ABC.
It's something that's real close as possible.
So these are all perfectly valid and fine ways to write out a label and caption. So, right, depending on what exactly the lab would be, right, some of these might be technically a little bit nicer to do than others. But for a single image, all of these are perfectly fine and perfectly valid. So, right, you can go through and you can say you can make it as wordy or as not wordy as you want. So for example, let's say this was a particular step of the lab. You could just say, you know, figure whatever number it happens to be, step 5 of the lab. Whereas maybe if I made all of us do this, maybe it's not beneficial to label it based on how I did it. Right? So maybe it's beneficial to say dominant versus non-dominant hand. Right? There's key terms that you might want to use depending on the context of the lab that are going to change how this is done. And also, if we had 14 sets of this, labeling the same thing 14 times might be a little tedious. So maybe you take that and you edit it a little bit and you put it inside of a table. What I'm trying to show with what we're going to be talking about here is that there isn't a perfect solution. Do things, right? You can improve a comment for hours, but there's no reason to do that. So as long as whatever is in the figure is defined and it is clear what it is, I will be happy with it. Right, so we're going to spend some, are there any questions about figures or labeling before we look at some graphs? Again, discuss with your neighbors some good and some bad things about this graph.
It is. It's all clear that we know Trout is the number generator and know that numbers were generated. Bad is there's no. Do we need a trend line? No, it's well, like we said, there's no like context of why. And what's the purpose? Because if we're doing random numbers, our purpose is either to have what people can perceive as random. I'm sure there'd be, like I said, like a trend line where they were guessing where it's going, or if they had a theory like that. Hey, like, oh, I'm gonna, let's see if it follows this line or something. That would be context around, so just, it was irrelevant, I guess. Yeah. Because you'd argue there might be generated actual description explaining the purpose, and this is just the result. So, yeah. So I part of that. Well, the only problem I really have is that the scope is way too wide. If we're looking at ranges of 1,000 and like 700, that's a really large scale. I mean, for numbers that can't exist.
My problem too is like the colors are like so close to the people spectrum. You can see them, but it's hard to like, just try to look at the ones that are really close.
Yeah.
So like you see like a brighter color, it kind of, it sometimes make can't tell, like there's orange, you have to like look closer. Something like that, it just kind of, how you use like to ensure.
I know it's hard, but let's talk about the good things first. What is something that's good about this example? What is something else that's good?
The different, there's a legend for the different colors.
What is something else that's nice about this graph?
It has the title. I think the title's kind of what it does.
I mean, that is the title.
Yeah.
Is there anything else good about this? There's a lot of, based off that, those spaces, I'm gonna make some more space for Beth. We'll leave a little room just in case we have something else. All right, what's something bad about this?
There's too much empty space underneath the numbers.
What are you talking about? I am lucky. I'm so lucky. Not good.
Definitely, that's a little nicer.
So you're saying that my random number generator between 1,000 and 750 probably shouldn't start at 0?
Well, then your data points are below that certain point.
Yeah, so I probably have a little too much white space there. That's something else.
Probably title it. Standard generated numbers between 750. Cause I didn't know that's exactly what it was.
Or we could caption it.
Use better color scheme, it's difficult to discern the differences between especially the yellow and orange.
How different do you think these colors look if you print them out in black and white?
Oh, they're not thinking about very much at all.
I will tell you right now that the bottom one stands out, but that top one is barely shows. You're turning them in on canvas, so it's not gonna be a problem. But that's something you would have to consider if this is something you were gonna print out. Also, yes, the colors are explicitly bad for a reason. What else?
There's still trend line, yet there wasn't, yeah, it's like a path that you were wanting to there. So, and see how close it that much.
Trend line would be something that would be a little dependent on context.
Yeah.
That's,
So if you were talking about the average number, a random number generator makes a trend line or an average line would be perfect. But again, context dependent on what it was. What are you talking about? Right there. They're on top of each other. So yeah, trial 2 does look like it only has 2. So if I'm being honest, I randomly generated numbers until they were essentially stacked on top of each other. They're different by 1, so we'll see it a little bit in the improved version on the next slide. So that would probably be something it's weird. I should point that out, that yes, There are 3 numbers there, just one is stacked on top of the other.
It just circles for all. These shapes in fact. Yeah, shapes usually. Especially in black and white.
If you want to go wild, you can do both. Not that hard in Excel. Some other programs, yes, Excel does. Anything else that you want to comment on for good or bad for this particular version of
I
it?
mean, they had no vertical, or, yeah, vertical, I don't know if that was good or bad.
Okay, so here's my thought process on vertical lines. Sometimes they are really helpful. Here, because everything falls into a 1, 2, 1, like a very specific one, I personally didn't, I looked at it. It looked very busy to me.
Yeah.
However, if you add them, I don't think it takes anything away from it. So we'll put it here. We'll put a question mark next to it because it might be dependent on exactly what it is you're trying to show. Yes.
The tax is, professional in the sense of advice for.
What are you talking about?
So let's see.
Silly.
Trial, number, and the random.
Consistency regardless. It is highly inconsistent with its capitalization. Just be consistent with it. Is the text big enough?
No. I can't read it back here.
So we can always increase text size.
It's very, context based for that, because if this is on a piece of paper, it's
Yes.
perfectly fine, but for
It-
screen.
You still wanna be able to read down a piece of paper.
It,
Yeah.
yeah, so this, you would have to play with it, but it's something to consider. In particular, I find that this one, it turns out, by default, Microsoft tends to do okay with font size, but we take this and we shrink it down onto Canvas. I can't zoom in forever on Canvas. You might want to have it be a little bit bigger or on the side, like just in case that thing. So just be conscious of it. So for Canvas, I think I can only zoom in to 75% on a normal document. So don't make the font too small. All right, anything else? Yeah, I guess that those were some things that you would point out. It's good, it's labeled, but boy howdy, is there a lot of white space there. So here's a slightly modified version of it. I want you to go over and discuss with your neighbors this version of the graph. I know I didn't fix the capitalization. That's fine. Don't bring it up again.
Promise the line change actually did hurt to this or almost exact same as Gen 1.
It's not quite nice. That was, maybe she's up here. Yeah. I was hoping that. Definitely. Cooler colors are black and then white. Because they got it. Also, because they have it on the ground, it makes you wonder.
So this is completely stupid, but accessibility.
Colorblind people can't see too.
The most common type of colorblind people. There are other types of colorblindness.
It's either meant to be an honor.
All right, so let's focus on the good/better. Then we can talk about the bad/worse. What is better or about this one?
Scan.
What else?
I think the color choice is better.
Better, but not great. What's the most common color blindness?
green.
I'm not colorblind, so it's not a problem.
Printing this out in black and white.
What? I think that's the name. I don't remember. If we printed it out in black and white, these all would show up better in comparison to the colors before. So in some instances, it's better. In some cases, it's worse because now we are dealing with possibly getting some colorblind problems. So when we get to bad, worse, I'll write color again. For the points. Anything else that's good/better about this one? All right, so we'll re-add color.
The other thing was it matches the graph. So the yellow matches with it, so I thought it really did.
You guys agree with that?
Legends happening in the ground.
I mean, I retrospectively, I should have shifted it over to the right a little bit more. It would have been funnier. But yeah, it looks like random number generator 1 and a little bit of 2 are actually data points. But they're not.
Fitted onto the graph or off it.
Yeah, so you can, again, this is assuming you're using Excel. You can just click a box and it'll move the legend to below the axis if you want to. Is there anything else that is bad or worse with this version of the graph?
I think the scale can possibly bring out a new problem here because we don't caption or so with the actual random gens would kind of explain more of their purpose, because thinking from a random number actual purpose, do we have any, would it be relevant to say the type of generation for the systems?
I mean, that's, right, that's the thing. Sometimes, right, we can put as many words as we want in this legend. It'll just get really busy, so that's why sometimes you'll just put that in the caption instead. Right, so this is me using the RAND generator in Excel. What are the rules for Excel? Well, I don't know what they are. I didn't write them, but if I said this is the RAND function in Microsoft Excel, somebody who really, really, really wants to know can go to Microsoft's website and figure out how the random number generator works there. But it wouldn't necessarily be part of the lab. Anything else good or bad, or sorry, better/worse about this graph here? Again, it's just context. In this case, I'm pretending that they are different. Random number generators, but yes, in reality, technically every single one of these data points should be its own data. But then you would have random generator 1 through 30. I don't know if that's nice stat. Is it any better seeing the 2 points?
Like, are they still combined together?
Yeah, but it's also the red and the green
Oh.
on purpose. So again, the shapes, good, right? Those would help. If I had a square and a triangle, it'd be a little clear that that square has a little hat on it. It's probably 2 shapes. If you have 3 sets of data, the square, triangle, circle are the ones you probably should be using. As you get more sets of data, it gets a little harder to start seeing the more shapes because you'll start having more spikes on them. So if you're gonna do shapes, hopefully you only have 3. Otherwise, like I said, it can get a little wild, a little fast. So I don't have another version of this, but right, we can spend hours making this graph better. Right, I could go through, I can fix the colors of the lines, I can add all the stuff you talked about in the last slide and on this slide, and we can fix it up. But it just takes a lot of time. At some point, you're gonna have to be happy with what you have. So make sure it's clear. So, make the modifications of, get the legend out of here. Maybe slap a caption on this instead of just having the title that gives a little bit more information. Point out the fact that there's 2 points right on top of each other. Get rid of the same color side, horizontal lines, call it good enough. There's no such thing as a perfect graph. So don't beat yourself up to do that. Any questions about graphs? Like I said, the program we're gonna be using does generate graphs. You might need to play with the size of the font a little bit, as well as I think you can change the thickness of the line just to make it a little bit clearer. But if you are generating a graph, these are things that you should consider. I personally am not colorblind, so if you want to use red and green, that's okay with me. But should be something we may be aware of moving forward in the future. Right. So I want to talk about some tables. This is, I kid you not, a replicated table of a student's turned in report from a couple years ago when I was an adjunct at a different school. A lot going on with this one that's wild. Wild. It's not wrong, it's just not good. Right, the information in here was correct. They just represented it very poorly. Right, I have no idea what my units are. Units are going to be extremely important. We'll spend time tomorrow talking about those. Significant big figures vary a lot. Again, we'll talk about that some more tomorrow, but right, we're going anywhere from 1 sig fig to 8. Pick some values and commit to it. And the word distance is broken up. So spend a little bit of time formatting your table such that this doesn't happen. So here's a better version. So this was, they took data as a group of 4. This was, the left one was one group, the right one was a different group. So we can see here the numbers are a little bit more evenly spaced out. They chose to do 2 sig figs based off of, 3 sig figs based off of their stuff. They put units on there, so they have their meters and their meters per second. So just overall, it looks a lot better than what it is. So something that we are going to be seeing when we look at the resistors is that resistors will come with some variance in them. Typically, it's about 10, depending on the resistor, it can range from 0.1 to I think the ones we'll be looking at are 5%. And so with that, we might need to go through and introduce this thing called uncertainty, which I'll talk about a little bit on the next slide. So if we're looking at this graph, this table here, this is me going through and taking their data and trying to make it as fancy as possible. I ended up going through and adding an average to it, right? An average, because there was 3 trials of the same thing. I averaged the distance that they launched their projectile. Talk about the uncertainty in a second, and I averaged out their speed value. So this little thing here is the lowercase Greek delta. It means uncertainty. Anybody know what uncertainty is?
Variation or error.
Yeah, so where does that come from? It can come from the actual device itself. So for example, resistors, like I said, they have some variance to their values. You're right, your ruler might not be 100% flush when you're measuring something. The human eye in general is not very good at distinguishing small details. If you're trying to match something up on a millimeter ruler, you might not be able to do so. So uncertainty can come from a couple different locations. I'm going to talk about how we're going to address it in this class, fully understanding that as you guys continue onward, the way that the different engineering majors approach uncertainty is a little bit different. So, because this is kind of a generalized class, I'm not going to do this. Also, you'll find that when you really need to calculate uncertainty, you will need to use integrals. So I will leave that for somebody else, not for me. Oh, I took that slide off. Let me, so, my bad. basically the uncertainty in this class, is we're just gonna read the values that are given to us. And then we are just going to use them. We're not gonna do any error propagation. So if the resistor band tells you what percent, it could be, that'll just be the value that you report. That's gonna be the only time we use it. I just want you guys to get used to the practice of acknowledging uncertainty, not necessarily doing those calculations. Like I said, everyone's got their slightly different rules to it, and it can get pretty expensive pretty quick because we're just trying to learn a little bit about circuits and like, we're just gonna do the acknowledgement part. Because I'm pretty sure it's electrical engineers have electrical engineers and chemical engineers. I know they have their own separate rules. So I'm not gonna get into them because there isn't enough time in the world for that. Typically it comes with your class. So any questions about lab reports or anything like that?
If we're being lazy and there's a bunch of numbers, can we just write out that every value is to this level of precision and then not have to show it the actual data because it's stated above?
You could. This is, right, it says this, period, end of sentence, take these columns out. Uncertainty for distance is whatever, uncertainty for speed is whatever. You can put it in the caption. If you have multiple tables that are gonna have the same ones, you can put it at the top of your results part. That way it's kind of, that way. Put it at the top if you do it, don't put it at the end. Because at the end, it's awkward because you're like, oh, I was supposed to know that, all the previous stuff. So if you're gonna do it by sentence, put it at the top. Any other questions? So that's all I have for today for this. So next week, like I said, if you're going to be doing the labs at home, please pick up a kit from the library. Otherwise, I have kits here that we'll be using in class. So I will see you guys tomorrow.